Two, formula 1, 2, 3, 4, and 5. So we're starting with limits, which actually don't even use any formulas. So when there are multiple terms in the denominator, I'm going to look for the biggest exponent in the denominator, and that is right here. It is the 20th power. So I'm going to multiply the numerator and the denominator both by 1 over k to the 20th power. So it's the limit as n approaches infinity of, I've got 3k to the 5th times 1 over k to the 20th, and that is going to be 3 over k to the 15th, minus 13k squared over k to the 20th, minus 13 over k to the 18th, plus 2k to the 11th over k to the 20th, plus 2 over k to the 9th, plus 8k to the 15th over k to the 20th, plus 8 over k to the 5th, plus 12 over k to the 20th. All over k over k to the 20th, 1 over k to the 19th, minus k squared over k to the 20th, 1 over k to the 18th, plus k to the 3rd over k to the 20th, plus 1 over k to the 17th, plus k to the 20th over k to the 20th, plus 1. When the variable is in the denominator, and I actually wrote k approaches infinity, or n, I wrote n, but the letter here is k, so I'm going to change that to a k. But as k gets bigger and bigger, and it's in a denominator, that makes the fraction smaller, approaching 0. So this fraction approaches 0. This approaches 0. This approaches 0. All of these in the numerator approach 0. In the denominator, this approaches 0. This approaches 0. This approaches 0. Because k is in the denominator, it makes that fraction get closer and closer to 0. So I've got 0 minus 0 plus 0 plus, and this one doesn't change with k, so plus 1. 0 over 1 is 0. The limit is 0. When there is one term in the denominator, it's easier just to split the fraction. So it's the limit as n approaches infinity of negative 7n over 4n. So that's negative 7 fourths. Plus 9n squared over n. So that would be plus 9n over 4. Plus 11 over 4n. Negative 7 fourths does not have a variable, so it will stay negative 7 fourths. 9n over 4 has an n in the numerator. When n is in the numerator, this fraction is going to get bigger and bigger as n increases, approaching infinity. And then 11 over 4n, it's the denominator that's growing, so it approaches 0. Negative 7 fourths plus infinity plus 0 is infinity, which means there is no limit, or the limit does not exist. So this last one has separate terms again in the denominator. The highest power in the denominator is the second power, so I'm going to multiply numerator and denominator both by 1 over n squared. So it's the limit as n approaches infinity of 5n squared over n squared. So that's 5. 9n over n squared. 9 over n. 11 over n squared. And then 3n squared over n squared. And 9 over n squared. So 5 is not affected by the n. It stays 5. 9 over n, as n gets bigger, This fraction will approach 0 because the fraction of the denominator is getting bigger. Same here. So plus 0 plus 0. This 3 is not affected. And 9 over n squared, the denominator is growing, making that fraction approach 0. So 5 plus 0 over 3 plus 0 is a limit of 5/3. Find the first term of an arithmetic sequence. That is formula 1. So we're looking for a sub 1, knowing that a sub 37 is 123. You don't know a1. The common difference is negative 2.8. N is 37 minus 1. Okay? So I can evaluate this here. Negative 2.8 times 36 is negative 100.8. So I've got 123 equals term 1 minus 100.8. So I can add this 100.8. So that's 123 plus 100.8. And that's 223.8. Find D for this sequence. The only way to find D is with formula number 1. So I've got A16, so term 16 is 44.5 equals A1, negative 32, plus D times n minus 1, 16 minus 1. So I can add that 32, 44.5 plus 32 equals 76.5. And that equals 15D. So divided by 15 is 5.1. Next 3 terms, and it is geometric. Okay, so, it is arithmetic. So negative 1 minus 7 will give me the common difference, and that is negative 8. So we're subtracting 8, so negative 1 minus 8, minus 8, minus 8. So those are my next 3 terms. Negative 9, negative 17, negative 25. Find the next 3 terms, and it is geometric. So R is 0.5 divided by 0.125. So R is 4. So 0.5 times 4 times 4 times 4. 2, 8, 32. And find n in this geometric sequence. Okay, so a sub n equals a1 times r to the n minus 1 power. So I can divide by 4, so that's 1, 5, 9, 4, 3, 2, 3, over 2048 divided by 4. Okay, so it does not want to give me that as a fraction, so I'm just going to be a little more tricky than that, and I'm going to divide both sides by 4 like this. 1, 5, 9, 4, 3, 2, 3 over 4 times 2048. Equals 3/2 to the n minus 1 power. Now I can do logs with a base of 3/2, an argument of 1594323 over 8192 equals n minus 1. Okay, so I can do log of the argument divided by log of the base. And I can add a 1. So I get 14.